You know that feeling when you start a new project, maybe you join a new company, or even just try to get a handle on your own sprawling personal code projects, right?
Oh, yeah, the classic onboarding scramble.
Right. And someone inevitably points you to, you know, the wiki. They tell you, like, everything you could possibly need to know is in there.
Yep, the mythical all-knowing wiki.
Exactly. So
Yeah.
you open it up, completely eager to learn how things work, and within about, I don't know, 5 minutes, you realize this place is a total ghost town.
It's so depressing.
It really is. The links are broken. The documentation describes a software architecture that literally hasn't existed for 3 years. The wiki isn't a helpful guide at all. It's just, well, a graveyard of good intentions.
Yeah, I mean, it's the classic documentation paradox, right?
A paradox.
Yeah, like the very second a human being hits save on a piece of technical documentation, it's almost certainly already out of date.
Oh, totally.
Ugh.
Because someone else pushed a code update while you were typing.
Exactly. Software evolves by the minute, especially now, but human typing simply can't keep up with that pace of change. It creates this massive friction between what a system actually is and what a human, remembers to write down about it.
Which is the exact core problem we're unpacking today for you on this deep dive.
And it's a huge problem to tackle.
It is. We are exploring a really fascinating article published on LinkedIn back in August 2026 by Maurizio Rizzari.
Right.
And we're looking at a piece of technology called the SYRAG KB Manager. That's KMEAB for knowledge base, just to be clear.
Right, which is a central component of this broader ecosystem known as Saragosis.
Yeah. And Rizzari introduces this really compelling concept of a living memory for a computer system.
I love that phrase. Living memory captures the ambition here perfectly, I think.
It really does, because we're looking at a system that fundamentally changes how a digital ecosystem understands itself.
Right. The SYRAG KB Manager doesn't just passively sit there storing information that some exhausted developer feeds it.
No, not at all.
It actively builds its own consciousness. I mean, it constructs an understanding of itself based entirely on what is tangibly running in the system at that exact millisecond.
So it's looking at reality, not a story.
Exactly. It prioritizes hard, verifiable facts over human fiction.
Okay, let's unpack this. Because the problem of the outdated handwritten wiki is so deeply ingrained in how tech operates.
Oh, it's practically an industry standard to have terrible documentation.
Right, so how does this KB Manager actually pull this off mechanically? I mean, software can't just magically document itself without some kind of structured intervention, right?
Well, mechanically, the KB Manager acts as the central information hub for the entire Syragos environment.
Okay.
But instead of presenting, a blank page waiting for someone to type up a summary, it literally goes out and inspects the reality of the machine.
Wait, this snoops around the system?
Basically, yeah.
Okay.
It scans the installed modules, it reads the live configuration files, it actually parses the raw code to find the living functions, the active classes, the open HTTP routes. It's pulling the facts directly from the bare metal of the system.
So it's like a house that automatically redraws its own architectural blueprints every time you add a new piece of furniture or knock down a wall.
That's a great way to put it.
You don't have to remember to hire a draftsman to update a drawing. You just, move the couch. And the blueprint magically redraws itself to reflect the new layout.
And then it serves that constantly updated blueprint in multiple formats, which is the really cool part.
Oh, right. It's not just a text file.
No, it runs a browser dashboard for visual navigation. It publishes static pages for specific users and modules. And crucially, it exposes an API.
Ah, so other software can talk to it.
Exactly. Other software components can query the knowledge base. It takes all those raw scraped facts and outputs them in two primary forms.
Which are?
Organized markdown cages that a human can actually read, and interactive nodes in a visual graph that map out how every single component is connected to the others.
Okay, I have to push back a little here, though.
Sure, go ahead.
If this system is just blindly scraping raw code, how is that actually readable for a human? I mean, let's say I write a messy, sprawling 5,000-line function with terrible variable names. We've all been there.
Oh, definitely.
If the KB Manager just scrapes that, doesn't it just generate a messy, sprawling wiki page?
Yeah.
You don't want a knowledge base that's just a raw copy-paste of a tired developer's terminal.
You've hit on the absolute core philosophy of the system right there, which Rizzari calls fidelity.
Fidelity.
Yeah. It isn't just dumping raw, unstructured code onto a page. It's actually extracting the underlying structure. So the metadata, the input parameters, the active network routes, and formatting them into a standardized knowledge base.
Right, so it organizes it a bit.
It does, but to your point about messy code, yes, if the code is a mess, the documentation will reflect that mess.
Wait, really?
Yeah, and that's actually intentional.
Wait, so it forces the ugly truth out into the open?
Precisely. The beauty here is that descriptions and pages are produced from verified facts.
So no hiding.
None. If a developer writes a tangled, horrible function, the KB Manager doesn't let them hide it behind a beautifully written, polite wiki page that summarizes what the function supposedly should do.
The classic, this function does X when it actually does Y and crashes.
Right. The documentation is the absolute unvarnished truth of the system. If you want better documentation, you are forced to write better, more structured code.
Oh, wow. That's a fascinating shift in accountability.
It really changes behavior.
And I assume this doesn't require someone to, like, manually click a refresh button to update the dashboard every time they fix their messy code, right?
No, not at all. The system operates on an auto-regeneration loop on startup, and whenever it detects important changes in the local system, it just automatically rebuilds the necessary pages.
So it's always watching.
Yeah, it has a configurable refresh cycle. It's constantly checking its local modules and updating the documentation without ever requiring a human to manually restart the service. The map always matches the territory.
Here's where it gets really interesting, considering the landscape of technology in August 2026.
Oh, I know where you're going with this.
Right. The immediate assumption anyone would make right now is, oh, they just hooked up a large language model to the code base.
Of course. That's what everyone does.
You assume they have an AI reading all that raw code and then writing a nice, easy-to-digest summary for the wiki. But that's the biggest twist in this entire architecture.
It is a very deliberate and honestly somewhat contrarian architectural choice.
Yeah.
In an era where AI is doing almost everything, writing emails, generating software, summarizing meetings, the SYRAG KB Manager severely limits the role of large language models. It puts a remarkably strict leash on them.
So why put a leash on the AI when it comes to documentation? It feels counterintuitive today.
Well,
I mean, it's like you hired a brilliant, world-famous editor for your autobiography, but you told them they're only allowed to organize the table of contents and they absolutely cannot touch or rewrite a single word of your actual manuscript.
What's fascinating here is that the underlying reason for that restriction comes back to a single word: traceability.
Traceability.
Yes. The creators of SYRAG understand that an LLM is, at its core, a black box of probabilities.
It's just guessing.
Right. It guesses the next most likely word. And because of that architecture, it hallucinates. It invents things that sound incredibly plausible but aren't actually rooted in reality.
And in technical documentation, a plausible-sounding hallucination isn't just annoying, it's actively dangerous.
Exactly.
If an AI summarizes a module and confidently tells a developer that a specific HTTP route or a security protocol exists, and it doesn't, that developer might build an entire feature on a complete lie.
And it breaks the whole system.
Right.
That's the exact danger they're avoiding. The KB Manager dictates that the text must stay completely faithful to the extracted code and metadata.
No creative liberties allowed.
Zero. LLMs do not create or rewrite the descriptions of the modules. The raw facts must remain pure, mechanical truth.
Okay, so if the AI isn't allowed to read the code and write the descriptions, what are the LLMs actually permitted to do in this ecosystem? Because they are in there, right?
They are, but they're only allowed to suggest semantic links between documents.
Okay, meaning what exactly?
They act exclusively as the connective tissue. The AI processes all these perfectly accurate, fact-based markdown pages and says, hey, based on the concepts discussed in this module's documentation, it's highly related to this specific user guide, and they should be linked.
Ah, so it builds the visual graph.
Yes, it constructs their relationships.
I see.
But by keeping the core text raw and using AI solely for finding connections, the system leverages all the intelligence and, navigability of semantic linking, but it doesn't sacrifice a single ounce of transparency.
So you get the AI's ability to see the big picture and categorize massive amounts of data, but you just don't let its probabilistic nature contaminate the actual ground truth.
Exactly. It's a hard refusal to replace original factual content with AI-generated approximations.
That makes a lot of sense.
It builds institutional trust. When you read a description in the SYRAG KB Manager, you know for a fact you're looking at a mechanical reality. You aren't left wondering if an AI hallucinated a parameter just to make the sentence flow a little better.
Okay, we've established how the system understands itself internally and how it actively restrains AI to keep its own memory accurate.
Right.
But a system can't just trust itself blindly, right? I mean, a hallucinating or compromised system might think it's perfectly healthy.
That's a very real problem.
So how does it check its reality against the outside world?
Well, a reliable memory isn't just about what you know internally. It's about how you validate that knowledge against external reality.
Okay.
And the KB Manager integrates with external sources to constantly verify itself. A major way it does this is through IPFS.
Which is the interplanetary file system.
Right, verifying its modules against a decentralized registry.
Let's actually break down IPFS for a second because it's crucial here for you listening.
Good idea.
Normally, the web works by location. You go to a specific URL to find a file. But IPFS works by content. It generates a unique cryptographic fingerprint for the file itself based on its data.
Yes, the hash.
Right.
Yeah.
So you aren't asking a server, what's at this address? You're asking the global network, who has this exact cryptographic fingerprint?
And the KB Manager uses those exact cryptographic fingerprints, those checksums, to verify its own identity.
Oh, wow.
It actively distinguishes between modules that are only running locally on your machine and modules that have been officially published to the Global Federation.
So it's comparing notes.
It is. It compares the local code's fingerprint against the global registry's fingerprint, and it explicitly flags any mismatches in the documentation.
So it's like a bouncer checking your ID against a global database to make sure your local software is who it claims to be.
That's a perfect analogy.
So if someone tampers with a local module, or if a piece of code gets corrupted, the system immediately knows because the math doesn't add up anymore. The fingerprint literally changes.
Exactly. It's a completely automated defense against supply chain attacks and configuration drift.
That is so smart.
And the system extends this external validation to scientific literature as well, actually.
Oh.
Yeah, the KB Manager can import research papers directly from Zenodo.
Zenodo, that's the massive open access repository developed under the European Open Air program.
Yep.
Right. Mostly used for hosting research data and academic papers.
That's the one. The KB Manager pulls those research papers in, automatically extracts and creates pages with the main metadata, and links directly to the source files.
Wow, okay.
So it weaves external, peer-reviewed scientific knowledge directly into its own internal graph of code and configurations.
But wait, this introduces a massive complication.
How so?
Well, we have this beautifully pristine, highly verified, AI-restricted, externally validated machine memory. It's mathematically flawless.
Sure.
But the article notes that humans are still allowed to add manual notes to these nodes.
They are.
If the machine's automated truth is so perfect, and human typing is what ruined the traditional wiki in the first place, like we talked about earlier, why let humans back into the process? Aren't we just inviting the ghost town back in?
I see what you mean. But if we connect this to the bigger picture, it's about recognizing that a complete knowledge base requires two distinct types of information.
Okay, I'm listening.
There is the objective machine truth, the code, the active network routes, the cryptographic checksums, that's the what and the how.
Right.
But then there is the subjective human context, the why.
Oh.
Why did the engineering team configure this module this specific way? What business problem were they trying to solve when they chose this specific security parameter over another?
Oh, that makes sense. The machine knows exactly what it's executing, but it has no idea about the boardroom meeting that led to that architectural decision.
Precisely. And the KB Manager bridges this gap by allowing manual human notes. But, and this is the critical design choice, it keeps them strictly isolated from the mechanical truth.
Isolated how?
When a developer attaches a note to a node, it doesn't overwrite or blend into the generated documentation. It is rendered as a completely distinct, visually separate element within the knowledge graph.
Oh. So it's like putting a sticky note on the outside of a glass display case in a museum.
Yes.
You can read the curator's handwritten context, and it adds immense value. But you aren't actually painting directly onto the priceless artifact inside the case. The artifact remains untouched.
That separation of concerns is what makes it work. It allows human wisdom, historical context, and project reminders to exist in parallel with the objective truth without ever corrupting the raw data.
You achieve perfect mechanical fidelity while still retaining rich human context.
Exactly.
Okay? But having a map of your system that is this perfect, this deeply interconnected, and this transparent, I mean, that sounds incredibly powerful for a development team.
It is.
But power usually comes with a massive target on its back. If this system builds a perfectly accurate, globally connected map of its own brain, you've essentially just created the ultimate treasure map for a hacker.
Oh, absolutely.
Right. If I breach this system, I don't have to spend weeks doing reconnaissance. Your KB Manager just hands me the master blueprints.
It represents the ultimate vulnerability if left unprotected. If a bad actor gains access to a fully populated KB Manager, they don't just see a random list of directories.
Right.
They get a semantically linked, easily navigable blueprint of every single function, network route, and configuration file in your entire enterprise ecosystem. They see the exact shape and logic of your system's memory.
So what does this all mean for the security side? If total internal transparency creates total external vulnerability, how does the KB Manager defend the living memory?
The architecture takes several hardline stances on security. First, it automatically redacts secrets and configuration responses right at the source.
Okay.
If a developer accidentally hardcodes a database password or an API key into a configuration file.
Which happens all the time.
Exactly. The KB Manager scrubs that secret before it ever renders it into the Markdown documentation or the API output.
It sanitizes the blueprints before publishing them.
Exactly. Second, it requires HMAC signatures for any sensitive operations coming from remote clients.
Let's break down HMAC for a second, just so everyone is on the same page.
Go for it.
Think of an HMAC signature like sending a locked briefcase to a colleague. But the combination lock on this briefcase isn't like a static 4-digit number.
Right.
The combination is mathematically generated based on the exact weight, ink, and paper fibers of the documents inside, combined with the secret password only you two share.
That's a really solid way to visualize it.
So if someone intercepts the briefcase in transit and swaps out a single page, the weight changes, the math breaks, and the lock permanently jams.
It ensures that the message absolutely hasn't been tampered with, and it proves the sender actually holds the secret key.
Right.
But the KB Manager goes even further than cryptographic signatures. It employs strict geographic restriction at the network level.
Geographic, you mean like GPS?
Well, network geography. By default, the critical endpoints of the KB Manager remain accessible exclusively from localhost.
Ah, localhost, meaning the physical machine itself.
Yes.
You have to literally be inside the digital house to open the safe. You can't request the blueprints from a server down the street, no matter how many passwords you have.
To reduce the attack surface, the system fundamentally assumes the outside world is hostile. And this highlights a major architectural philosophy here.
That is.
Total internal transparency requires total external defense.
Oh, I like that.
If your system's memory knows everything and makes that knowledge beautifully easy to navigate, locking down the critical endpoints is literally the only way you can safely operate in a trustless environment. You're building a fortress of truth, which means you need incredibly thick walls to protect it.
It's a fascinating balancing act. You design the system to be completely transparent to itself, pulling back the curtain on every messy piece of code and configuration, but you make it totally opaque and inaccessible to anyone trying to poke around from the outside.
And that tension is what makes the SYRAG KB Manager so effective. It sits at the absolute center of the SYRAGOS ecosystem, providing the structured memory. The module docs, the user guides, the academic paper references, the semantic network of relations. Every other component relies on this heartbeat. They query this information to build out user dashboards, to prepare automated software packages, or to publish validated snapshots of this knowledge base back out to the IPFS network.
It's the beating heart of the system's intelligence, constantly taking its own pulse.
Beautifully said.
So synthesizing all of this, what we're looking at with the SYRAG KB Manager is a massive, fundamental shift in how we handle the concept of knowledge in complex digital ecosystems.
It really is a paradigm shift.
We're moving away from the era of manual, error-prone corporate wikis that become ghost towns at the absolute moment they're published.
We're entering an era of self-generating, highly verifiable living memories. Memories that actively prioritize hard, extracted facts over the plausible hallucinations of an AI.
It all comes down to those core values. Maurizio Rossari highlights transparency, traceability, and fidelity. The code running on the machine is the only truth.
Right.
The documentation is just a highly structured reflection of that truth. And AI isn't the author making up the story. It's just the librarian helping you find the connections between the facts.
Exactly.
It's an entire architecture designed to fix the ghost town problem by ensuring that the map always perfectly matches the territory.
Because the territory is dynamically drawing the map itself every single millisecond.
Which leaves me with a final, slightly provocative thought for you to mull over today.
Oh boy, let's hear it.
We've spent this time dissecting how software systems are evolving toward these perfect auto-generating living memories. Systems that rigorously, almost ruthlessly, separate objective mechanical facts from subjective human notes. The sticky note on the glass case.
The separation of what happened from how we feel about what happened.
Right. So what happens when we try to apply this exact framework to our own human organizations or even our personal lives?
Oh, that's heavy.
Imagine trying to build a personal knowledge system that auto-documents your actual behavior with that same mechanical fidelity.
That sounds terrifying, honestly.
Right. An app that tracks your raw data, how many hours you actually focused on a task, what you actually ate, how you actually spent your money, and presented that as the unvarnished, objective truth of your day.
Just the raw facts.
Just the facts.
Yeah.
And then, completely separate from that raw data, it allowed you to add your human notes, your excuses, your feelings, your inherent biases about how you thought the day went.
It would be a rather stark confrontation with reality for most people.
It really would. If we rigidly separated our own unvarnished raw data from our biased self-evaluations, would we actually be able to handle the fidelity of our own living memory?
I don't know if we could.
Or would we find ourselves missing the comfort of the ghost town, where we could just pretend the outdated optimistic wiki was still the truth?
That is a fascinating question.
It's definitely something to think about next time someone points you to a broken link in a corporate document. Until next time, keep diving deep.